Hey everyone, Mr. Regan here, and today we are going to be diving into exploring direction of collisions and force as we begin to dive into our focus question, what are forces like in a collision? Today for our experiment, you're going to be looking to answer that focus question. And in order to answer that focus question, we're going to be gathering data about the forces in a collision from a set of experiments. So not just one experiment, but two experiments. To do this, we will be using the objects you see below to create collisions. So we got a ruler, we got a set of rubber balls and golf balls as well. And for each collision that we create, you're going to be observing the direction of the force acting on both objects after they collide and the change in the velocity they create for our different objects. So as we create our collisions, we know that the bouncy ball or the rubber ball here is going to be less massive and the golf ball is going to be more massive. And as we make them collide in different ways, we'll be observing the direction of those forces and the changes in their velocity before and after they collide. So how are we going to set up these experiments? In our first experiment, you're going to be rolling the golf ball along the groove in the ruler. So that would be that kind of middle section here. And you're going to observe what happens when it collides with the object in the middle. So as you roll one object towards the other, you're going to create a collision with object A and B, and that collision needs to stay on the ruler. When you create that collision, you're going to see that we have a data table down here where you're going to collect your velocity and direction of force data. So we'll have object A and B. Object A will always be at the end of the ruler for our first experiment. Object B will always be in the middle. And when you roll it, you're going to push it towards object B in order to observe the velocity changes and the direction of the force after they collide. So for example, if we put two rubber balls on our ruler here and we roll it towards each other and they collide, you're first going to look at, did object A speed up, slow down, start moving, stop moving, or change directions after it collided? So object A rolled into B. What happened after the collision? Which of these velocity changes occurred? For object B, same thing. Which of these velocity changes occurred when you hit it? So it should be one of those highlighted yellow sections. After you do that, you're then going to infer about the force exerted during the collision. So for example, if we have rubber here, what direction was the force exerted on A during the collision? So you're going to have to think about what velocity change or what kind of change in motion do we have and what kind of force would create that change in motion. Would it be a force to the left, force to the right, or no force at all? And then you're going to make sure you then think about B. Same thing. What direction of force would cause its velocity change? So if it stopped moving, what direction of force would be needed to make it stop moving? Same with speed up or slow down or so on and so forth. You'll do that for 3 trials with 3 different variations of objects. Feel free to run the trial multiple times to get accurate data to record in our trial data table here. So just to recap, you set up your collision, run the collision, make sure you keep the collision on the ruler. They shouldn't be banging off the rulers at all. Record your data and you repeat that for all the different objects we use in the different variations of the collision. Once your group's done there, then you're going to run a new collision trial or experiment, In the second experiment, you're going to be rolling both objects along the groove at each other to see what happens during that collision. So A and B will be on the opposite side. You're going to roll them down that middle groove, have them collide, and observe the same data. There'll be 3 trials with 3 different pairings of objects. When you do this, you'll need to look and describe what kind of velocity change. So A will always be on the left, B will always be on the right. So how did A's velocity change after the collision? So once A collides, what happened after it collided? Did it speed up, slow down, start moving, stop moving, or change direction? Same with B. Speed up, slow down, start moving, stop moving, change direction. And then once you have your 2 velocity changes, you'll need to decide what direction of force would cause that change. So if it's rolling this way and it changes direction, maybe it goes to the left, what kind of force would need to change that motion going from right to left? Or if it stops moving, what kind of direction would need for the force need to get it to stop? So on and so forth. So just like the last one, okay, we're going to set up our collisions, but this one will be on opposite ends. Okay. You're then going to run the collision, keep the collision on the ruler. If it falls off, just redo it. No big deal. Record the data, repeat it for those 3 trials. And that's how we're going to run our collision experiment. So ask yourself, do you understand how to set up the collisions within both experiments and how to set up and record your force and velocity observations in the data table for both experiments? Go ahead and complete your survey. If you put your X in yellow or red, reach out. And as always, good luck.